So I realize that some of you still may not believe me. So let's calculate this with actual numbers. Okay, so let's see. Here are the predictions from the empty model. And notice that for each thumb, each person, we just predict the same mean for everybody, and that's 62. That's represented by this blue line, right? And so we could actually look at the residuals, square them, see what we get, right? Here I've also put down the group predictions, right? And the group predictions for group 1 is 61, and the group prediction for group 2 is 63. And we could also look at the sum of squares from the group model. So let's get the squared residuals from the empty model. So here I put the predictions, but I'm just going to do a little bit of subtraction to get the residuals. And then I'm also going to make some space for myself to square those residuals. To get the error or the residual, we always want to do data minus model, right? So here's our data here, thumb, minus the model, 62, the empty model, right? And so here we have 64 minus 62 is 2. Let me line them up. 61 minus 62 is negative 1. 58 minus 62 is negative 4. 66 minus 62 is 4. 63 minus 62 is 1, and 60 minus 62 is negative 2. So let's think about this 60 right here. It's that blue dot right here at 60 that's in group 2, right? And so I'm just going to draw a little circle around him, right? And then, so my residual from the empty model looks something like that. And then I'm going to square that residual, right? And so instead of 2, it's negative 2 squared, which is 4, right? And so that is like that. That is my little 4 right there, right? And imagine that I do that for all of my dots, all 6 dots, right? So here 1 squared is 1, 4 squared is 16, negative 4 squared is 16, 1 squared is 1, and 2 squared is 4. Right? So you could see my squared residuals from the empty model, and I've put those in blue. Now I'm going to put the squared residuals from the 2 group model, and I'm going to write them over here. Here's my residual, and here I'm also going to make some space for my squared residuals. Right? All right, so to get the residuals, it's the same idea. Data minus model, right? And so my data is thumb, and my model is now over here, right, in the group prediction. So it's 64 minus 61. Let me see if I can line it up well. All right, so I'll put a 3 right there. And then there's 61 minus 61, which is 0. 58 minus 61, which is negative 3. And then 66 minus 63, which is 3. 63 minus 63 is 0, and 60 minus 63 is negative 3, right? And then I could square those residuals. And just to illustrate what I'm doing, here we could take this data point, 58, in group 1, and that data point is right here, right? I'm taking the residual, which is a negative 3, and I'm squaring it to get 9, right? And so that's 9, right? And I'm going to do that for all of my data points. So that 0 squared is 0, 3 squared is 9, 3 squared is 9, 0 squared is 0, negative 3 squared is 9, right? And even without doing the addition, we could see, oh, the sum of all of these is going to be a lot smaller than the sum of all of these, right? And so here we have 18 is the sum of squares for this group. So the sum of squares for this group is 18, right? And the sum of squares for this blue group to over here is also 18. And so it's 18 and 18. And then what I told you was that these two sum of squares would be bigger than these two sum of squares. So let's see if that's actually true. So this first group sum of squares is going to be 16 plus 4 is 20, 21. So the sum of squares here is 21. And then also the sum of squares here is 21, right? And so 21 is bigger than 18. 21 is also bigger than that 18. So when you add them together, 21 and 21 is bigger than 18 and 18, right? And so that's actually true no matter what the means actually are. Whatever the means are for this group, these two groups, that mean is going to minimize that sum of square. And those minimized sum of squares added together are going to be smaller than these not minimized sum of squares. And that's going to be a real key in why the two-group model has a smaller leftover sum of squares than the empty model does.